Okay, good morning friends. I am Dr. D N Pansare, Assistant Professor, Degree College, Aurangabad. As we see previous lecture, we have started the organic chemistry. In this chapter, there are seven, in this paper, there are seven chapters. Now we can see the first chapter, that is structure and bonding. Now the new concept is inductive effect. First, we can see the definition of the inductive effect. What is inductive effect? The inductive effect is the permanent state of the polarization. The electron density is a sigma bond between two unlike atoms is not uniform. The electron density is more dense towards the more electronegative of the two atoms. The inductive effect is a distance dependent phenomenon. Okay, we can see here the one is electropositive atom and one is electronegative atom. For example, carbon and halogen is there. X means halogen. It may be fluorine, chlorine, bromine, or iodine. We know that the carbon is electropositive elements. That's why the delta positive is here, and halogens are electronegative. That's why on the X atom is delta negative. The atom X above acquires a slightly negative charge, in bracket delta negative, and the carbon atom a slightly positive charge, delta positive, which means the bond is polarized. Now we can see here the carbon chain or alkane chain. It is attached to the electronegative groups. Here X means halogen. We can see here the halogen atoms is pull the electron towards itself. That's why the more charge is available or more electron is pulled. Carbon first, then second, then third, and then fourth. Here, if negative atom is attached to the Y, then electrons are pulled towards electronegative atoms, like here delta negative. Means electronegative species pull electron towards itself and electropositive atom donate the electrons. If the electronegative atom X is connected to the chain of the carbon atom, then the positive charge is relayed to the other carbon atoms, chlorine, with its positive delta charge. Expert a pull on the electron of the C2, but the pull is weaker than it is between X on the chlorine, between the X on C1. The effect rapidly dies out and is usually not significant after the second carbon atom or at most third. The inductive effect is permanent but relatively weak and can be easily overshadowed by the electronic effects discussed later. There are two categories of the inductive effect, the electron withdrawing minus I effect and electron releasing, that is plus I effect. The latter is also called the electron donating effect. In the image above, X is the electron withdrawing and Y is the electron donating. The relative inductive effect are measured with the reference to hydrogen. We can see here the series. Here on the middle is the hydrogen. This species nitrogen is more electron withdrawing groups. That's why priority is the first. Nitro group is more electronegative than acid group, then fluorine, then chlorine, then bromine, iodine, ether, alcohol, benzene, and hydrogen. After the hydrogen on the right sides, these are the tertiary alkyl group. Tertiary alkyl group is the donating groups, then secondary, then primary, then single carbon chain. Means electron withdrawing effect are less from left to right. Now we can see what is minus I effect, or what is meant by minus I effect. The I effect, minus I effect is the seen around a more electronegative atom or group, and electron density is higher there than elsewhere in the molecules. Electron withdrawing group include hydrogen, nitro, halogen, nitro, cyano, carboxy, ester, and alkoxy groups. Next point is the plus I effect. What is meant by plus I effect? The plus I effect is observed among less electronegative atom of the molecule by electron releasing or electron donating groups. The alkyl groups are usually considered electron releasing or electron donating groups. The next point is hydrogen bonding. What is meant by hydrogen bonding? The hydrogen bond is the intermolecular force that form a special types of dipole-dipole attraction when a hydrogen atom bonded to a strongly electronegative atom exists in the vicinity of the another electronegative atom with a lone pair of the electron. Intermolecular force occurs between the molecule. Other examples include ordinary dipole-dipole interaction and dispersion force between bonds are generally stronger than ordinary dipole-dipole and dispersion force, but weaker than true covalent and ionic bond. Now we can see either here the diagrammatic form of the hydrogen bonding. Origin of the hydrogen bonding. The molecule capable of the hydrogen bonding includes the following. Here there are three different examples, that is here ammonia, second is water, third is hydrogen fluoride. That is the ion pair. Here red color image or circle indicate that these are the lone pair. On the ammonia, nitrogen is one lone pair. In the water, there are two lone pair, and hydrogen fluoride, three lone pair is there. We can see here nitrogen, oxygen, and fluorine is the electronegative species. That's why delta negative, and hydrogen is positive. Here dotted means hydrogen bonding. The lone pair responsible for hydrogen bonding in the NH3, water, and hydrogen fluoride. Notice that in each of these molecules, the hydrogen is attached directly to the highly electronegative atom, causing the hydrogen to acquire highly positive charge. Each of the highly electronegative atoms attains a high electronegative charge and has at least one active lone pair. At the second level, have electron contained in a relatively small volume of the space, resulting in high negative charge density. Lone pair at higher level are more diffuse and result in the lower charge density and lower affinity to positive charge. Here we can see water molecule, two water molecules is there. Okay. In the other molecules, for example, the first molecule of hydrogen is interacting with another molecule of electronegative atom like oxygen, and this is called as hydrogen bonding. Consider two water molecules coming together, close together, and formation of hydrogen bonding. The diagram shows the potential hydrogen bonds formed when a chlorine ion. Chlorine, although the lone pair in the chloride ion are at least 3 level and would not normally be active enough to hydrogen bond, they are made more attractive by the full electronegative charge on the chlorine. In this case, we can see here water molecule, four water molecules there. Center is chlorine. Chlorine is electronegative and it is bonded to the 4 hydrogen atoms. Then we got here hydrogen bonding. Here dotted blue color line draw here. That means hydrogen bonding is present between water and chloride ions. Types of hydrogen bond. There are two types of hydrogen bond. One is intramolecular hydrogen bonding and one is intermolecular hydrogen bonding. Now we can see the intramolecular hydrogen bonding. Intermolecular hydrogen bondings are those which occurs within one molecule, single molecule. These occurs when two functional groups of the molecule can form hydrogen bonds with each other. In order for this to happen, both hydrogen donor and hydrogen acceptor must be present within the one molecules and they must be within close proximity of each other in the molecules. For example, intramolecular hydrogen bonding occurs in the ethylene glycol between its two hydroxyl groups due to the molecular geometry. Intermolecular hydrogen. Intermolecular hydrogen means there are two different atoms or two different molecules. For example, ammonia, two other molecules. One is ammonia and one is hydrogen. Okay, here we can see the hydrogen is bond formation with another molecules of electronegative atom, that is nitrogen, and here hydrogen bond is present. Second example is ammonia and water. One of the hydrogen of the water is bonded with another molecules of ammonia electronegative atoms, that is nitrogen, and we call here the hydrogen bonding is present. Properties and effect of the hydrogen bonds. And boiling point. When we consider the boiling point of the molecules, we usually expect molecules with a larger molar mass to have higher normal boiling point than molecule with smaller molar mass. Here, these are the different types of compound. Here, molar mass 18, 20, 17, 34, 36, 34. And normal boiling point is 373 is the water. Here, boiling point is less. When molecular mass is increases, the boiling point is decreases. Is a simple phenomenon. On viscosity, the same effect that is seen in the boiling point as a result of the hydrogen bonding can also be observed in the viscosity of the certain substances. Substances capable of the forming hydrogen bonds tends to have a higher viscosity than those that do not for hydrogen bonds. Generally, substances that have the possibility of the multiple hydrogen bonds exhibit even higher viscosity. Factors affecting or factors preventing hydrogen bonding. Electronegativity. Hydrogen bonding cannot occur without significant electronegativity difference between hydrogen atom and its bonded to. Thus, we see molecules such as B.Sc which do not partake in hydrogen bonding. B.Sc exhibits a triangle pyramidal molecular geometry like that ammonia, but unlike N.Sc, it cannot hydrogen bond. This is due to the similarity in the electronegativity of the phosphorus and hydrogen. Both atoms have an electronegativity of the 2.1 and thus no dipole moment occurs. This prevents the hydrogen bonding from the acquire the partial positive charge related to the hydrogen bond with the lone pair of the another molecules. That means if the electronegative is present, that means one is more electronegative and one is more electropositive atom is required. Atom size. The size of the donor and acceptor can also affect the ability of the hydrogen bond. This can account for the relatively low ability to chlorine to form the hydrogen bond. When the radii of the two atoms differs greatly or are large, their nuclei cannot achieve close proximity, then the interact result in the big interaction. Conjugative effect. For example, this is the 1,3-pentadiene is a molecule with the conjugated system, and another is the cinnamaldehyde is the naturally occurring compounds that has conjugated system. In a chemistry, conjugated system is a system of the connected the p atom orbital with delocalized electron in a molecule, which is a gender lower the overall energy of the molecule and increase stability. It is the conventionally represented as having the alternating single and multiple bond. Lone pair radicals or carbanium ion may be part of the system, which may be cyclic, acyclic, linear, or mixed. Chemical bonding in conjugated system. For example, this is pyridine, furan, yeah, 7-member ring. Here allylic system, that is En3, 3 electron, and here 4 electron alternating system. That means the alternating pi bond and single bond and presence of number of pi bonds. If pi bond is present alternately, single bond pi bond, that structure will be present conjugation. Steric effect. Steric effect are non-bonding interaction which influence the shape, conformation, and reactivity of the ion and molecule. Steric effect component electronic effect which usually dictate shape and reactivity. Steric effect resulting from the repulsive force between the overlapping electron cloud. Steric spatial interference of the group. Steric effect means the more bulky group is attached to the another molecules. That means the steric effect is there. We can see the chair conformation of the structure. This is R2R group is attached on the above side. That is a fill orbital interaction. Means here more crowding site is there. An atom group is surrounded by the many other atoms is said to be sterically crowded or hindered. Here, 3 methyl groups is attached to the bromine, that is steric interaction or steric effect. Steric effect. Ethyl bromide primary attack is easily. We can see here primary alkyl group. OH is easily attacked backside. Second is isopropyl bromide attack is possible. But if at the tertiary bromide, attack is impossible because 3 methyl groups are bulky and this OH group is cannot backside attack here. That is the steric effect. Here also SN1, SN2 reaction is there. Tertiary group is there on the bromide attached plus KOH, no reaction. Difficult to attach because here 3 bulky group is present to the carbon atom. That's why no reaction is happened. The same example. Okay, thank you very much.